This is lesson 4-3 from the Algebra Readiness textbook. For today's lesson, grab a sharpened pencil in your notes packet. Start working the study guide problems on pause, then come on back when you're ready to continue the lesson. In the first problem, you are asked to use exponents to represent the expression x times x times x times x times y times y. I see that x is being repeatedly multiplied 4 times. I can represent that with an exponent, x to the 4th power. Y is being repeatedly multiplied 2 times, so I can represent that as y to the 2nd power. X to the 4th, y to the 2nd means x to the 4th times y to the 2nd. The next question, a microscope can magnify a specimen 10 to the 3rd times. How many times is that? It's asking me to evaluate 10 to the 3rd. In expanded form, 10 to the 3rd is the same as 10 times 10 times 10, which is the same as 1,000. In the next problem, I'm asked to use the order of operations, parentheses, then exponents, then multiply or divide from left to right, then add and subtract from left to right. To solve this problem, simplify 8 plus 2 to the 2nd plus 6. Well, this is the given expression. The first thing that I need to do is simplify the parentheses. Inside this parentheses, I use the order of operations, which means I need to use exponents first, or simplify the exponent first. 2 to the 2nd power is 4 plus 6. Notice the exponents the parentheses do not go away. Then I simplify what is in parentheses. 4 plus 6 is 10. And now the parentheses don't mean anything. So that can go away. Then 8 plus 10 is 18. Okay. Today's learning targets are to use prime factorization to find factors, and then to identify the greatest common factor. Let's go over some vocabulary. Much of this is review from previous work in math. A prime number. A prime number is an integer greater than 1 with exactly 2 positive factors, 1 and the number itself. So it has exactly 2 factors, 1 and itself. Make sure you get that written down. So here are some examples of prime numbers. 2 is prime because the only number that divides into 2 is 1 and itself. There is no other number that divides evenly into 2. The same thing is true about 3. 1 times 3, 5 is 1 times 5, 7 is 1 times 7, but those are the only numbers that go into those. As opposed to a composite number, which is the opposite of prime. A composite number is an integer greater than 1 with more than 2 factors. Here are some examples. 4, 6, 8, 9, 10. 4, for example, has the factors of 1 and 4 and 2. 6 has the factors of 1 and times 6 and 2 times 3. See how there's more than just 1 in itself? And the same is true for 8, 9, 10. The number 1 is neither prime nor composite. By definition, a prime number has 2 factors. See this? A prime number has exactly 2 factors, 1 and itself. So 1 does not have 2 factors. 1 only has 1 factor. So it's neither prime nor composite. All right, enough for the definitions. Let's try. State whether each number is prime or composite and explain. 23. The number 23, I think about what numbers go into it. The only numbers that go into it are 1 and itself. So we're going to say this is prime because exactly 2 factors. 1 and 23. 129 is composite. Here's where those divisibility rules will come in very handy. When I add 1 plus 2 plus 9, I get 12. 12 is divisible by 3. So I know that this number is divisible by 3. I don't even need to know what that number is or what it equals when I divide by 3. I just know that 1 and 29 are not the only 2 factors. So I can say composite, more than 2 factors. And how did I find that so quickly? I used the divisibility rules I learned yesterday. Which numbers between 10 and 20 are prime? So 10. Let's start. 10, oops, that's not going to do it. Pause the video, give this one a try, and tell me which numbers between 10 and 20 are prime and which ones are composite. Then come on back to compare your answers to mine. All right, hopefully you got these same numbers that I did. Notice all of these numbers right here have only 1 and 11, 1 and 13, 1 and 17, 1 and 19 are the only numbers that go into them, and that's not the same case for the composite numbers of 10, 12, 14, 18, and 20. All right, good review. Let's go on. Prime factorization, that's also something you talked about in 6th grade. Writing a composite number as a product of its prime numbers. Now there are 2 methods. You can use a factor tree and write the factors in order from smallest to largest. Then you use exponents to indicate the repeated factors. My, that's a lot of exclamation points. Apparently we're really happy about all of these steps. So we're going to do this. If you need to pause the video to get the notes down, please do. Use a factor tree to write the prime factorization of 825. Well, you are going to start off, you write 825 here. Then I start thinking about what numbers go into 825. When I look at the number 825, I start using my divisibility rules. So I'm going to start with 8 plus 2 is 10, 10 plus 5 is 15, 15 is divisible by 3, so I'm going to say 275 times 3. Now, you might have noticed it ends in a 5 and divided it by 5 first. That would be okay too. Then I believe you learned to circle your number once it was prime, and then continue to work with the remaining number. 275, I notice ends in 5, so I'm going to do that rule and say 5 times 55. And again, 5 is prime, so I'm going to circle it. 55 is divisible by 5, 5 times 11, and then both of these are prime. So what is the prime factorization? I list the numbers I circled in order from smallest to biggest. 3 times 5 times 5 times 11, but I'm not done there. You need to list repeated factors as exponents. 3 times 5 squared times 11 is proper notation for the prime factorization of 825. And if you actually multiplied 3 times 5 squared times 11, it would equal 825. All right, you try. Write the prime factorization of each number. Pause the video now, make your factor trees, and then come on back to compare your answers to mine. For 72, I took 8 times 9. Then for 8, I took 2 times 4. And 9, I took 3 times 3. Then I took 4 and I broke it down into 2 times 2. I listed my factors from least to greatest, and I got 2 times 2 times 2, or 2 to the third, and 3 times 3, which was 3 squared. Letter B, 121. I broke that down into 11 times 11. 11 is prime, so that's 11 squared. 225. I noticed 225 could be divided by 9 because 5 plus 2 is 9, and that's divisible by 9, so 225 must be divisible by 9. Then I broke that down into 5 times 5 times 3 times 3, and I rewrote that as, notice I put the 3 squared first, and then the 5 squared, so I put the bases in order from least to greatest. Letter D, 236. I noticed that 236 is an even number, so it's divisible by 2. 2 times 118. Then 118 is also even, so I again use 2 times 59. Now I have my prime numbers. 2 squared times 59 is the prime factorization of 236. Let's go back to writing down some notes. Greatest common factor. What is a greatest common factor? It's also known as the greatest common denominator. If you ever see that, it means the same thing. Let me write what that means. Greatest common denominator. You'll want to write that down in your notes because you might forget it and it might sneak up on you and come again and you'll be like, wait a minute. When have I ever heard of that before? Greatest common factor and greatest common denominator mean the same thing. So what is it? Now, this is going to be on your quiz where you will have to give the definition of the greatest common factor. It is the biggest factor that is the same for 2 or more sets of numbers or expressions. You can solve by listing the factor pairs in the prime factorization. If there are no common factors, the greatest common factor is 1. Let's find the greatest common factor of each pair of numbers or expressions. So starting with A, we've already learned how to do a factor tree, so let's do that one again. Okay. 40. I know that 40 is divisible by 10 because it ends in a 0. Then I know that 10 is 2 times 5 and 4 is 2 times 2, and these are prime. I'm not going to write the prime factorization just yet. I'm going to use 6 times 10 here, and this is 2 times 3, that's prime, and 2 times 5, also prime. Now, the greatest common factor is simply taking whatever is in common amongst my circled values. So, for example, I have 1, 2, and 1, 2. They both have a 2 in common, so I'm going to write down a 2. Then I see they have another 2 in common, so I'm going to write down another 2. I also see, let's see, this 2, there's a third 2 in the first number, but there's not a third 2 in the second pile of numbers, so not going to use that one. There's also a 3 on the right here, but there's not a 3 on the left, so that's not in common. I do see that there is a 5 in common, so I'm going to write that down. 2 times 2 times 5 is 20. So 20 is my greatest common factor. The same thing is true if you have variables. Don't be scared of these variables. I know sometimes it seems like it's a little scary because there's letters there, but don't be intimidated by that. Let's give it a try. First thing you're going to do is do the factor tree for just the numbers. 6 is 2 times 3. Well, those are both prime. So if I write all of my prime factors, it's 2 times 3, and then let's write this out in expanded form. A times A times A times B. Now, to keep things easier, I'm going to write the other one in red. 2 times 2 is the same as 4. So 2 times 2, and then let's write the variables in expanded form, A times B. Now, to write the greatest common factor, I look at these numbers and I pick out what's in common in the blue list and in the red list. I'm going to highlight what's in common. I see 1, 2 is in both lists. So I'm going to write down a 2. I see there's a 3 in the left blue numbers, but there isn't one in the right. So that one is not in common. I see there's a 2 in the right, but not 2 2s in the left. So that's not in common. Now let's look at the A's. I see there's an A in common, so I'm going to write that down. There's another A in common, so I'm going to write that down. And then this last A here, there aren't 3 A's in both lists, so I'm not going to write that A down. And then lastly, there's a B in both sets, so I'm going to write the B down. Now I'm ready to write this as 2A to the second B. Okay? All right, now I want you to give some a try. Let's try these. We're going to first practice doing ones like these first with just the numbers. Let's try those. Use prime factorizations to find each greatest common factor. I'm going to walk you through this one, and then I'm going to let you pause the video and try it. 8 is the same as 2 times 4. 4 is then broken down into 2 times 2. So 2 times 2 times 2 is the prime factorization. 20 is 5 times 4. 4 is broken down into 2 times 2, so 2 times 2 times 5. Now the greatest common factor is what's in common in both lists. I see that there's a 2 and that there's another 2 in common, so 2 times 2. Now this third 2 is not in common in both lists. This 5 is not in both lists, so they don't count as part of the greatest common factor. Then I simplify. 2 times 2 is 4. 4 is my greatest common factor. Right? Now I would like you to pause the video and try the next one. In fact, try the next 3 problems that are in your notes packet. And then come on back and compare your answers to mine. All right, your prime factorization of each, and let me divide these up so you can see a little bit better. I ended up with, on the left, 2 times 2 times 3. On the right, I ended up with 3 times 29. Now, what's in common between both lists? I do not have a 2 in common. There's not another 2 in common. There is a 3 in common, so I'm going to write the 3 down. Notice I only wrote 1 3. I just write down what's in common. And there isn't a 29 in common. So my greatest common factor is 3. All right, with these, the greatest common factor, here are my prime factors for each side. And what's in common, I highlighted. 2 times 3 times 3 gave me 18. Okay, then there's the next one. Even with 3 numbers, you can find a greatest common factor. It's the same process. Use factor trees, list all of the factors. So the factors of 48 are listed in black right here. The factors of 80 are listed right here in blue. The factors of 128 are listed in green. So the greatest common factor, being what they have in common, I see so far that they have 1, 2 in common. What else do they have in common? Well, I see another 2, and another 2, and another 2. They have 4 2s in common. The 3 is not in common, the 5 is not in common, and these 2s are not in common. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 16 is the greatest common factor between all 3 of those numbers. All right, now let's try some that involve variables. 12r to the third and 8r. Remember, the first thing you're going to do is make a factor tree of 12 and 8. So here's what I've got. Then the greatest common factor is picking out what's in common. I have a 2 in common. I have another 2 in common. So 2 times 2. The 3 is not in both lists. This third 2 is not in both lists. I do have an R in common, but this second and third R are not in common to both lists. So 2 times 2 is 4. My greatest common factor is 4R. Let's do one more of those together. Sometimes that's confusing. So I list off my prime factorization of 15 and 45. Then I write my exponents in expanded form. To find my greatest common factor, I write down what is in common in both lists. I see a 3 in both lists. I see a 5 in both lists. I see an M in both lists. I do not see a second M or an N or a second 3 in both lists. So then I write down what is in common, a 3, a 5, and an M. Then I simplify it and get 15 times M or 15M. Now I think you're ready to try some on your own. Pause the video and do the next couple problems, and then come on back to compare your answers to mine. All right. When I write my answers, my factors, I get 2 times M times N, and 2 times 2 times M times M times N times N. Boy, that's a mouthful. So, what's in common is a 2, 1 M, and 1 N. The rest of these are not in both lists. So 2MN is the greatest common factor. The last one, comparing both lists, what's in common? Well, this one has a 3, but the other list does not. This one has a 5, this one has a 5. This has a 5, that has a second 5. This one has an X, this one has an X. They don't have a second and third X. They both have a Y, but not a second Y, and these two 2's are not in common. Let's summarize with the greatest common factor being 5, 5, and X, or 25X. All right, I think we've got it. And so we're going to cross this problem out. I won't give you anything that awful. And then let's give the homework a try.